Okay, this is the second lesson for vectors. Now, actually, vectors is very easy. The concept is very easy. Yesterday, we had a lesson on vector. Okay, today I'm going to finish off the concept. Okay, after that, we are going to do past year questions to see how to apply the concepts that we have learned. Okay, so for this particular lesson, we are going to learn about parallel vectors, which we have done a bit the previous lesson, and also collinear points. Okay, now let me start off with parallel vectors. Now we learned the previous time that if this vector is called A, okay, it means from point A to B, from point A to B, that's how I represent this vector AB. If it's represented by A, vector A, then this is how I write it. Now if I have another line that is parallel to this AB, okay, let's call this CD. Parallel to it, not only parallel but having the same length, then this would be vector A also. That means CD will be equals to A also. So these are what we call equal vectors, right? Same direction, same length, or same magnitude. Okay, now let's say we have another line that is parallel to AB and CD. Let's call it EF, but it's only half the length of CD and AB. Then this will be half A. Okay, or if I have another line that is twice the length of AB, then I call this GH, and GH is pointing in the same direction, then GH is equals to 2A. Okay, now what I'm trying to show here is that as long as two vectors are parallel or two lines are parallel, I can write, for example, GH is 2A, right? I can write GH is, for example, 2 times of AB. Okay, now as long as I can write GH, or I can relate GH with AB by a certain multiple, a certain number, that means this number, let's say K, I call this K, right? Where K is a constant. Constant can be a number like 2 or 3 over 2 or half or 4 over 5 or whatever. Okay, as long as I can write GH equals to K times of AB, then this means that, this implies that GH, okay, this line or this vector, right, is parallel to AB. Okay, or you can say that this vector GH is parallel to this vector AB lah. Okay, but I can also say that this line GH is parallel to this line AB. Okay, now let me give you another example to clarify this. I can actually write this as A. Okay, but can I write this as A? I cannot write this as A, okay? Because when I write this line in this direction as vector A, right, only a line in this direction with the same length can be called A, okay? But of course, I can draw another line here, then I can have this vector A, but I can have like minus B or something like that, okay? It can be in terms of another vector, but it cannot be like I draw like that. I draw like that, then I call this A. Cannot. Alright? If I want to draw like that, vector A, then it has to be in this direction and having the same length. That's why if I have another vector, let's say 2a here, then definitely these two vectors are parallel. Okay, so let me give you an example. If this vector is a minus 2b, right? Okay, if I multiply this by 2, that means I draw a line, and this one is in this direction, okay? I have a line that is twice the length of this, then it be 2a minus 2b. Okay, so can you see that, let's say I call this AB, then this one CD, then AB is 2 times, is half of CD. Okay, or I can say that CD, this vector, is twice of AB. So when I say when I can write it like that or write it like that, where they are related by a constant, right? Then I can say that AB, this line is parallel to CD. Okay, so that is the whole idea behind parallel vectors. As long as I can write AB, this vector, is equals to k times of, let's say, CD, where k is a constant, then this means that, this symbol implies that AB, this line, right, is parallel to CD. Okay, so that's the whole idea behind parallel vectors. Okay, now I'm going to extend this concept a little bit more to talk about collinear points. Now collinear, this word is actually split into two. It comes from this word co and then linear. Now linear, you know, means straight. Okay, this COL comes from this word collective. Collectively so it means all together they are straight. Alright, so if I tell you A, B, and C are collinear, what does that mean? It means that all together, collectively, they are straight. That means, let's say this is A, this is B, this is C. I can draw a straight line through them all, through all these points A, B, C. This is the meaning of collinear. That means they lie on the same straight line. Okay, now how do we prove that two lines are collinear? Very simple. Number one, there are two conditions. Two conditions for 3 points to be collinear. The two conditions are AB, this line, must be parallel to, let's say, AC or AB. That means if this is AB, okay, then this is BC, right? These two lines must be parallel, pointing in exactly the same direction. Okay, not only that, the second point is they must have a common point. And in this case, the common point is A. So that means AB, AB is one line, right? Then we have AC. This is another line, right? Can you see that we have a common point A? If we have a common point A, then of course AB is parallel to AC, and of course they lie on the same straight line, this straight line. Okay, now contrast it with just now the example. Can I say that A, B, and C D, A, B, C, D, are they collinear? The answer of course is no. Why? Although they are parallel, you see AB, AB, this line right is parallel to CD, correct? They are parallel, but they do not have a common point. And because they do not have a common point, they are not collinear. Okay, they are only parallel. Alright, so let me clarify the difference between these two. Parallel vectors, as long as you can write this vector equals to k times of this vector, they are parallel already. Okay, whatever is here, AB is parallel to whatever is here. Okay, for collinear, then you need two things. Let's say ABC, the points ABC, right? You must have AB, this equals to, let's say k times. So just now I use AC, right? It can also be BC. As long as you have a common point. So you must have a common point, and in this case it is B. Alright, the common point can be A, B, or C depending on the question. Alright, so that is the concept behind this. Now, when I write AB equals to KBC, what does this imply? It implies that AB is parallel to BC. Okay, so with this, I'm going to start doing this O-level question. Okay, now let's try this question. This question is considered intermediate. It's not a basic question. We start with intermediate, not easy. Okay, now you must follow the method and the strategy that I'm going to go through here. If you follow exactly what I teach you, right, the steps, then you will find this topic very easy. Okay, now first step is to read the question and then update the diagram. Alright, so I'm going to write here, the strategy, very important. You must update diagram. Okay, label the diagram. As you go along, right, you do part 1, part 2, part 3, part 4, you must update your diagram. What do I mean by update your diagram? Later I'll tell you. Okay, now the question says this: the position vectors of A, B, and C. Now, the previous lesson we learned what position vectors are. Position vectors means from the origin to go to A. How to go from the origin to A? To go from origin to A, they say is 6A. 6A. Now, in your question, right, O-level question or your exam question, when you see vectors bolded here, right, it means that it's a curly thing here. They won't draw the curly thing because by convention, when they type out, right, they will only bold the vector. Okay, so this A is a vector, B is a vector, A and B are vectors. They bold it. They are trying to tell you that these are vectors. Alright, now I'm going to update this diagram now. That means label the diagram. Okay, how do I do that? OA, you see, position vector of A is this one, right? So OA is 6A. Very good. So that's done already. They labeled for us. That's done already. Then OB. By the way, you don't have to write all this. No need to write this. I'm writing this to tell you what position vectors mean. Okay, so 6B. So O to B is 6B. Okay, we are done. This is 6B. No need to label. I'm just telling you only. Okay, then OC is 3A plus 3B. OC is 3A plus 3B. Okay, so 3A plus 3B. You see, I put the curly thing at the bottom. Okay, I'm going to erase all this now. Okay, we are done with this one already. So for this vectors question, you must read the question and then update your diagram. Otherwise, right, you won't be able to solve the problem, the question. Okay, now that I've labeled all these, I can cancel these already. Of course, you don't cancel in the exam, you just put a tick. Okay, I'm trying to tell you that I've labeled whatever I need to on the diagram already. Okay, ON equals to NB. ON equals to NB. What they're trying to tell us is that this length equal to this length. So what I want you to do is to write here 1 unit, circle it, 1 unit, circle it. So this whole length, okay, actually the midpoint, the middle of this OB, right, is N. And then because this way is 6B, right? 6B, then this is the middle. It means that I'm now going to relabel it. This way is 3B. Here is another 3B. So that in total, this whole thing is 6B. Okay? In total, this whole thing is 6B. Now, very important to label the parts, the small parts. This is like part of this whole line, right? This is like part of this whole line, right? Try not to label the whole thing. You label by the part is better. Why better? Because if later they want you to find MN or NM, then you will know that this is 3B. Or if they want you to find NC later, you know that this is 3B. Okay, so you label the parts. Use this strategy and it will help you later. Okay, so this is done. I'm done with this already. Now the next thing they tell me is MC equals to 1/3 OC. MC here is 1/3 of OC. So this is 1 unit, alright? But I write one part I write one part because this 1 unit and this 1 unit, they are different length, right? Okay, so I'm going to write one part here. This is 1 and this is 3. Okay, let me write here for you. When they say MC equals to 1/3 OC, right? Many students they don't know how to interpret this. Okay, so let me teach you how to write it in a very easy to understand way. You write all the unknown on one side as a fraction. MC is here, right? This OC is here, right? You divide both sides by OC, you will get this. Okay, now what is the good thing about writing it in this way? It tells me that MC is one part. There, I've written here already. And OC is 3 parts. So OC is 3 parts. That means this must be 2 parts. Okay, you need to label all this. Otherwise, when it comes to more difficult questions, you won't be able to solve the whole questions and get full mark. Okay, so that's how you should rewrite this part here so that you can get the ratio more easily and you won't make any mistake here. Okay, now we are ready to start solving the question. OM. How to go from O to M? Okay, that's the part that we need to do now. Okay, can you see that OM, right? Okay, let me write here. OM. Okay, how do I travel from O to go to M? It's actually just 2 out of 3 parts of OC, right? 2 out of 3 parts of OC. So it's just 2 out of 3 OC. And what is OC? OC is 3A plus 3B. Okay? Leave the vector alone. The vector I mean A. So it's just 2 over 3 times 3. So you get 2A. 2 over 3 times plus 3, you will get 2B. So that is your answer. Okay? For OM. Alright? Okay, now next actually I would want you to label the answer here. Okay, so you write here 2A plus 2B. Here to here is 2A plus 2B. Okay, now next part 2. This is what I mean by update your diagram. Alright, so that you know that OM, this vector is 2a plus 2b. You will need it later, so this is done already. Now how do I find AM? To go from A to M, I'm going to draw a line now from A to M. You see, it's like taking a bus. I want to take a bus from Ang Mo Kio to, let's say, MacRitchie. Okay, no direct bus, so I got to go by this way. I got to go this way, right? And this way, because it's against this arrow, so I'm going to write here, AM, the answer is minus 6a. Okay, and then now I'm going to travel this way. Correct? And this way, it has the same direction as just now, that 2a plus 2b. So it's a plus 2a plus 2b. So the answer is minus 4a plus 2b. Okay, so that's the answer. Alright. Okay, now what is the next thing they want us to find? Done already. Okay, so I'm going to label here. I'm going to label this one as minus 4a plus 2b. Okay, because definitely later I probably need to use this to help me. Alright. Okay, now how to find AN? AN is, AN is from here to here. Correct? Again, there's no direct bus. You actually have a bus from from here to here. You actually know the bus is minus 4a plus 2b, right? But you don't know from here to here what is the vector. You don't know, you see. So you have to go by this way, this and this. Okay, but this, because you are going in the opposite direction, so you need to AN, you write minus 6a, then plus 3b. Now you know how important it is to label the parts and not the whole thing, so that very quickly you can see, this 3b, this 3b, and then what is this, what is this, you see. So that's the reason why. Okay, now that we have these three, let's see what they want us to do. Part A we are done. They say use your answers in part, this part and this part, to explain why A, M, and N lie on the same straight line. Now, they are very nice to you. They tell you to use these two parts to help you solve the answer for, solve part B. Okay, so for A, M, and N to lie on the same straight line, what they're trying to ask you to do is to prove that they are collinear. Okay, collinear, if you remember just now we learned, for 3 points to be collinear, firstly, they must be parallel. That means I must be able to write AB equals to K times of AC. Okay, then they must have a common point, and the common point in this case is A in this case that I given you. Okay, so two things. Firstly, you must be able to write this, because this means that AB is parallel to AC. Okay, and then you must state, they have a common point A. Alright, okay, now let's try and see whether we can do that. You look at this. AM and AN, they have a common point A, right? So you already satisfied one of the condition. Okay, now what you need to do now is to be able to express AM as a multiple, like K times of AN. Okay, so that is what you need to do. Okay, now how do I do that? Okay, I'm going to show you this way of doing. Okay, so you have AM and you have AN, right? You start with any one of them. AM, you write exactly what you see here, minus 4A plus 2B. Am I correct? Okay, correct. Okay, now I want you to write the next line. Write as what? You write as the other vector minus 6a plus 3b. Okay, then you put bracket. Do you agree that this is your an? Whatever I written here is your an. I'm not done yet. I'm trying to tell you that this is one way you can do it. Okay, now you ask yourself, what number times this will give you minus 4a? What number times this will give you minus 4a? Okay, very simple. I want I want 4, right? So it's 4 over 6. You see, I don't want the 6 here, I divide by 6. I want the 4 here, I times 4. Okay? So, this is the answer lor. But of course, you must write it in the simplest form. So this is how I normally will do this kind of question. It's a very fast method. Okay, I repeat. How do I get 4 over 6? Okay, wait. Let me rewrite. Okay, so firstly, whatever is here, I copy exactly. I want to tell the examiner I know that AM is equals to minus 4a plus 2b found from B part 2. Correct? Okay, now I want to link this AM to AN here. So I simply copied this AN. Oh, sorry, I think I made a mistake here. It should be minus 6. I simply copied this here to here because this is my AN. Correct? This whole thing here is my AN. Okay, Okay, so I copied this here. Now, I want this line to be equal to this line, right? Okay, I repeat. I want this line to be equal to this line. Right now, they are not equal. How can minus 4a be equal to minus 6a? Cannot, right? Okay, so the only way to make them equal is to multiply by a constant here. I don't want the 6, I divide by 6. I want 4, I times 4. That's why it is this times, this 4 over 6 times this, that will give me this. Okay, don't believe you take 4 over 6 times 3, right? You will get this. Okay, as long as one of them is correct, the other one will be correct already. Then you reduce this to the simplest form, and once you have this, you can make your conclusion already. Okay, what's the conclusion you must make? Explain. Yeah, I'm now explaining. Okay, this whole thing is the working for part B. You say since okay, never mind, I lazy, I write since here. Since AM equals to whatever, okay, AM is parallel to AN. Okay, that's the first thing I must write. And since they have a common point, what's the common point? A, right? Common point A. Then I can say that A, M, and N are collinear. Or you can say lie on the same straight line. Okay, so that's all there is to this. Alright, okay, so this is the working, and most of the time students don't know how to explain this kind of question. Okay, so please learn it well today. Okay, lastly, write down the ratio AM and AN. AM and AN. Okay, so the answer is actually here. We know that AM part C is equals to 2/3 AN, right? Okay, now for this kind you don't write the vector anymore, okay? When it's a ratio, you don't write the vector anymore. So do you agree that AM over AN is 2 out of 3? Using the same method that I taught you here. Okay, this is a very powerful method, trust me. You write all the unknowns on one side. AM is here already, right? You divide both sides by AN, you will get AN here, leaving the 2 over 3 here. This means that AM is 2 units, AN is 3 units. So your answer is just 2 is to 3. Finish already. Okay, we'll stop here today.